2. Let's see what's going on here. This is equal to the, I'm sorry, I want to look at these values. If I say I look at f at pi over 6, right? This is going to be equal to the cosine of 3 times pi over 6, which is equal to the cosine of pi over 2, right? So what we're doing is it just takes that value of pi over 6 and just just speeds it up to where the cosine would normally be pi over 2, and the cosine of pi over 2 is 0, right? So we're going to be plotting with these values over here, and notice we get through all our values just going from 0 to 270 degrees, rather 0 to 360 degrees, right? Okay, so if we plot this function over here, we're going to have 0 is going to, the value of the function is going to, at 0 is going to be 1. At pi over 6, the value of the function is going to be 0. Now notice before it didn't get to 0 until 90 degrees. Now it's going faster, it's already 0 at pi over 6. And our next one is going to be pi over 3. And at pi over 3, the value of the function is going to be negative 1. So it's looking like this. And at pi over 2, where the cosine would be 1, it's already up to 0 again. Again, what I'm doing is I'm plotting the pi over 3s. Okay. And last, at 270 degrees, or 2 pi over 3, the value of the function is 1. Okay? And now it's still an even function. That doesn't change. Manipulating the a and b does not change the fact of being odd or even. So it's an even function, so I can go negative pi over 6, negative pi over 3, negative pi over 2, and I can do negative 3 pi over 2. And I can just come around like this. And I get my function f of t. Okay? Okay. Now I'm going to do an example that uses both a and b, not 1. And for that, I am going to say look at function f of t is equal to 5 times the sine of 1/2 t, or the same as t divided by 2. Now dividing t by 2 is, oops, sorry. I'm going to look at the function f of t is equal to 5 times the sine of 1/2 times t, that's a t, right? And dividing, multiplying by 1/2 is the same as dividing by 2. All right, so let's see how we can do this now. So what we're going to do is we're going to have t. We're going to have t divided by 1/2, right? Because if we're multiply, whatever we multiply by here, we divide by when we're figuring our coordinates out, which is the same as multiplying by 2, so that's 2t. We're dealing with the sine, so we're going to look at the y-coordinate, and the transformation on the y-coordinate is multiply it by 5. Okay. So let's see. So, or we'll just do our quadrantals. You can do more if you like, just to get an idea of what it looks like. So we're going to have, say, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay? Now next, I'll fill in the y coordinates at those angles. I'm going to switch to another marker. Well, the sine of the y coordinate at 0 is still 0. At pi over 2, it's 1. At pi, it's 0 again. At 3 pi over 2, the sine value is negative 1. At 2 pi, it's 0. And now I can just multiply these by 5. This is still 0. This is 5. This is 0. It becomes negative 5. This is still 0. And dividing by 1/2, because my b is 1/2, I am multiplying everything by 2. Dividing by half is multiplied by 2, so this is 0. This is going to be pi. See how this is stretching out now? This is going to be 2 pi. This is going to be, if I multiply by 2, it's going to be 3 pi. And if I multiply by this is going to be 4 pi. So now what happens is I've actually stretched out the period. Now before I graph it, now the period of this new function is always going to be the period of the old function divided by the absolute value of b, right? So in this case, the period was 2 pi for the sine function, and I'm dividing by the absolute value of 1/2, which is just going to be equal to 4 pi. Okay, so this is an important formula. The period of your new function when you have a b other than 1 is going to be the period of the old function, which in this case is 2 pi. For the tangent and cotangent, it's just going to be pi. And we're dividing by the absolute value of b, which is 1/2. B is 1/2. And it gives us a period of 4 pi. And you're going to notice that we don't repeat values until we get to 4 pi. And let me just make a note that a is equal to 5 and b is equal to 1/2 in this one. Okay. So if we go ahead and graph this, we're going to be graphing at these guys over here, the modified angles. So we're going to go 0, pi, 2 pi, 3 pi, 4 pi. And what that's going to give us is, at pi, the value is 5. And so it starts at 0. It's going to go up to, at pi, it's going to be 5. At 2 pi, it's 0. At 3 pi, the value is negative 5. And at 4 pi, it's 0. Again, it goes to both values. And again, we can do the same thing. And again, it's still an odd function. Negative 2 pi, negative 3 pi, and minus 4 pi. So what we do is we go over here. We go over here. It's an odd function, so it's just going to repeat like the same over here. And again, it repeats within 4 pi radians. Okay. All right. Now, the last thing I want to do is I want to introduce to the secant and the cosecant functions. So we're just going to graph them. And the cosecant, if you remember, the cosecant of t is equal to 1 divided by y, which is the same as 1 divided by the sine of t. Now, because of that, what we're going to do is we're going to start out by graphing the sine function in order to graph the cosecant function. And we're going to graph it at, say, pi over 2, pi, we're going to do 3 pi over 2, and we're going to do 2 pi. And we're going to do negative pi over 2. We're going to do negative pi. We're going to do negative 3 pi over 2. And we're going to do negative 2 pi. All right. Now, if I were graphing the sine function, here's 1, here's negative 1. And the sine function, remember, is going to start out at 0, go to 1, come back to 0, come back to -1, go to 0, and go the opposite way here. Go to -1, go to 0, go to 1, and go to -1. Okay? So what we have here now is we have the sine function. But when the sine function is 0, we have 1 divided by 0, so it's undefined here. All right, so this we cannot have, the sine function cannot be 0 because the cosecant is 1 over the sine function. So what I'm going to do is I'm going to put a dotted line or an asymptote everywhere the sine function is 0. Okay? Now, when the sine is 1, the cosecant is also 1. So what is going to happen is wherever the sine is 1, the cosecant is going to be 1, and it's going to come up like this. It's never going to touch the asymptotes, but the cosecant function is what I have drawn in blue. Okay. Now, if you look in your book, it'll give you the properties for the function, but what we have here is basically the range is going to be -infinity to -1 and 1 to -infinity, because you notice we start at 1 and go up and -1 go down. It's going to be all real numbers except for multiples of pi. Notice that 2 pi pi, 0, -pi, -2 pi is undefined. It's going to be an odd function, and it's also going to have a period of 2 pi. Okay, but you'll have a table of those in the book. Okay, and the last one I want to take a look at is I want to take a look at the secant function. Okay, and that'll be the last one I do. Now, the secant function, or say the secant of t, is equal to 1 divided by x is equal to 1 divided by the cosine of t. Now, that tells me that the secant is not defined anywhere where the cosine is 0. So basically what we're going to do is the same as the last time. We're going to, and it's going to be an even function, and it's going to have the same range as the cosecant. We're going to do the same approach. We're going to start out by graphing the cosine function. Now, if we start out by graphing the cosine function, we'll look at 0, we'll look at pi over 2, we'll look at pi, we'll look at 3 pi over 2, and we'll look at 2 pi. And we'll look at negative pi over 2, we'll look at pi, we'll look at 3 pi over 2, and we'll look at, oh, these should be negative, and we'll look at negative 2 pi. Now, what is the cos? Well, we're between 1 and -1. And the cosine starts at 1, at pi over 2 it's 0, at pi it's -1, at 3 pi over 2 it's 0, and at pi over 2 it is 1 again. It's an